Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. This lecture will be about the neurulation process. Before neurulation process starts, there is a process will develop at this stage. It's called the notochord process. The development of the notochord process occurs when the mesenchymal cells migrate from the primitive node to form a midline cellular cord known as the notochordal process. As you can see in this diagram picture, that this is the notochord process. Here is the primitive streak, which is sited on the epiblast, and here is the primitive node. Starting from this point, the migration of cells will get to this direction cranially until it reaches the prochordal plate, which represents the future mouth. This is the notochord process. The notochord is a cellular cord that forms the first longitudinal midline axis around which the vertebral bodies are organized and is the basis for the axial skeleton. Here, this is the primitive streak, and this is the site of the notochord, which is located between the ectoderm and the endoderm. Here it starts from the primitive node and reaches the prochordal plate. Another picture shows the notochord process, which becomes canalized and forming a hollow tube. The notochordal canal. It's communicating with the primitive pit. The neurulation is the process that refers to the folding process in vertebrate embryos, which includes the transformation of the neural plate into neural tube. The embryo at this stage is termed the neurula. Here, this is the notochord and this is the ectodermal layer. At the beginning, this notochord will give signal stimulation to the overlying ectoderm at this site, lead to the formation of the neural plate, which starts folding. And the center of the plate sinks, forming the neural groove. The edge of the plate is elevated to form the neural folds. Neural folds fuse and form neural tube. Here, this is the neural tube. It has two pores, the cranial pore and the caudal pore. They will be closed later on. Anteriorly, it forms the brain. Posteriorly, develops into the spinal cord. Here you can see again the ectodermal layer. This color shows the site of the neural plate induced by signal stimulation from the underlying notochord. Here the plates start to sink in the midline and forming the neural groove, which will later on is converted into the neural tube. You can see this green color represents the site of the neural crest cells origin. They appear here at the crest of this groove. Later on, when the tube is formed, they detach from this area and migrate in different directions, participating in the formation of different organs in the embryo. Here again, the notochord appears in this slide, induces the overlying layer of the ectoderm to form the neural plate. Now, this is the neural groove, and the neural tube is completely closed. Here, you can see the neural crest cells. The notochord is still present. Here you can see the neuroepithelial layer already showing signs of elongating cells. Now the neural groove is forming. And the last one shows the completely closed neural tube. This is the notochord and this is the overlying ectoderm. Here in this slide you can see the neural crest cells. And this is the neural groove, not closed completely yet. underlied by the notochord in the mesoderm between the ectoderm and the endoderm. And as you can see bilaterally to the notochord, this is the intraembryonic mesoderm connected with the extraembryonic mesoderm. Here, the intraembryonic mesoderm bilaterally divides into paraxial part, intermediate part, and the lateral part. These are the three parts of the intraembryonic mesoderm which occurs bilaterally to the notochord. Thank you for your listening and good luck.